Hi there. Now in this last part, part 4, it is given that the mass of the pulley is 0.5 kilograms. And we've got to state the magnitude of the tension in the chain which supports the pulley. In part A, when P is in motion, and in part B, when P is at rest on the ground and Q is moving upwards. So if you'd like to have a go at this and haven't done so already, just give you a moment to pause the video. Do come back when you're done and I'll run through the solution and you can check yours against mine. Okay, welcome back if you had a go. Well, let's just start with part A, when P is in motion. When P is in motion, let's just take this pulley here. What we've got is tensions in the two strings. The tensions are going to be pulling down on the pulley, like so. And those two tensions are going to be equal but opposite to the tensions that we had originally in part 1 of the questions. So both of these are going to be T newtons. Don't forget also that the pulley has weight. It's got a mass of 0.5 kilograms, so there's going to be the weight of the pulley pulling down as well. Put that in there as 0.5 g, the mass times the acceleration due to gravity, newtons. Now these will be the only forces wanting to pull down on the pulley. So what's that magnitude of the tension in the chain going to be? Well, if we call that tension, okay, let's just say we call it T1 newtons. Then we've got to find T1. And to do this in part A, we'll just label that as the diagram for part A. In part A, to do this, all we've got to do is apply Newton's second law of motion in, say, an upward sense. That's force equals mass times acceleration. So applying that, we've got all of that tension in the chain, T1 newtons, acting in the positive sense. But then we've got to subtract from this 2T and the weight, 0.5 g newtons. So we've got minus 2T and minus 0.5 g. Now this is the resultant force acting on the pulley, but the pulley is in equilibrium, so that resultant force must equal 0. So therefore, rearranging this equation, T1 must be equal to 2T, if we add it to both sides, plus 0.5 g. Well, in the first part of this question, we worked out that that tension T was in fact 1.47 newtons. Okay, so that answer there, okay, for the tension T was 1.47 newtons. So I've just got to double that. That's 2 times 1.47, okay? And then we've got minus 0.5 multiplied by the acceleration due to gravity, 9.8. And if you work that out, what you get is 7.84 newtons. So that's going to be the force then in the chain. Okay, so that's part A. Now for part B, let's have a look at the pulley when P hits the ground. Now when P hits the ground and Q is moving upwards, there's going to be no tension in any of the strings. So all we've got then is the weight of the pulley, which is 0.5 g newtons, and we've got the tension, let's now call it T2. It's going to be different from the tension that we got here. That's all we've got acting on the pulley. So when it comes to, again, resolving upwards, then we have got T2 minus 0.5 g must equal 0. So therefore, T2 equals 0.5 g, and if you work that out, 0.5 times g, 9.8, turns out to be 4.9. So that's our tension in the chain then when P hits the ground.